3 Series Protection Relay is a highly functional, economical protection relay for the utility and industrial, for the low, medium, and high voltage applications. 3 Series relays effectively eliminate the need for expensive, discrete components. 3 Series relay has 3 types of relays for the protections of feeder, motor, and transformer. 350 can also be used in capacitor bank protection. The relay can be operated from the front panel or with intuitive configuration software and Vista, locally or remotely. There are 16 programmable logic elements provides great application flexibility. Arc flash mitigation via zone intertripping, flex curves, and multiple elements and setting groups. Relays has advanced switchgear monitoring and relay health diagnostic information. 3 Series support multiple communication protocols, including IEC 61850, 61850 Goose, Modbus TCP/IP, Modbus RTU, DNP 3.0, IEC 60870-5-104, 103, and OPC-UA IEC 62.541, IEC 62.439-3, PRP, and HSR, IEEE 1588 PTP. 3 Series relay warranty is 10 years as all GE multilink relays. Types of the front panel for 3 Series: draw-out and non-drawout. Both can simplify the commissioning and maintenance. For the draw-out type, the relay can be removed from the chassis with the wiring still connected. For the non-drawout type, the wiring can be pre-wired to the Euro-style terminal blocks, then plug into the relay. The size of the front panel is 203 mm by 158 mm. The rear side size is 173 mm by 101 mm. The depth of the relay is 200 mm. The product identification label is located on the side panel of the relay. This label indicates the product model, serial number, and date of manufacture. In the front panel, 3 Series has 4 lines by 20 characters LCD display allows visibility under varied lighting conditions. There are 10 or 12 color-coded LEDs to indicate the type of event. Below the LEDs, there are 10 push-button keypad for access to device, interrogation, change of setting, and control commands. At the bottom, USB port allows the user to do the quick connection with Vista software. Most 3 Series relays have 1 copper and 1 fiber Ethernet ports. The auto code with 5E will have 2 fiber Ethernet ports. For the draw-out type relay, columns A, B are for output relays. Column C is for digital inputs. Columns D, E are for CT, VT inputs. Column F is for communications, RS485 and IRIG-B inputs. For the non-drawout type relay, columns A is for output relays. Column B is for digital inputs. Column C is for communications. Columns D, E are for the CT, VT inputs. The Vista SR3 setup software is one software works for 3 types of the relays. It can program and modify settings, read and write setting files, read metering values and monitor status, read pre-trip, transient and event records for post-mortem analysis, upgrade 3 Series relay firmware, and each relay has its own firmware. And Vista SR3 setup works under Windows 7, Windows 8 and Windows 10. M2 family relays MIF, MIV setting files can be imported into 3 series platform. There are 6 types of configurable input gates: OR, AND, NOR, NAND, exclusive OR, and exclusive NOR. The number of gate inputs of trigger is 8 and 4 for the block sources. 1 or on flag ended as trigger or block source. Quick setup allows user to configure main settings from different screens in a common window. Relay status, nominal frequency, current sensing, voltage sensing, configuration of main protection like phase, ground, neutral, time over current, and instantaneous over current. Protection summary use one single screen to show summarized information of settings for protection and control elements. Output relay assignments for the elements. User can view the enable, disable status of control elements, as well as navigate to the respected protection element screen on one button click. Event recorder of 1 millisecond time stamping records the sequence of events and relevant parameters. Transient record captures the waveform as an instance of element operation input or menu command. The fault report captures analog signals of the time of the trip, stores the last recorded values in non-volatile memory. Extended and enhanced protection and control features. Positive sequence under voltage. Second harmonic blocking to avoid unwanted trips during normal operations. Dedicated 10 inputs lockout through non-volatile latch to simplify logic for lockout operation. 3 series can monitor the integrity of both the breaker trip and closing coils and circuits. It also monitors the breaker operation parameters like tripping, closing, and spring charging time, number of permissible operations, magnitude of breaking current, mechanical wear, and contact wear. CT field supervision and VT fuse field supervision are provided to avoid undesired operation of some protection elements. Wide input ranges for CT-VT. 350 phase CT primary is up to 6,000 amps, and VT ratio range is 5,000, which means permissible primary VT voltage can be reached to 550 kilovolts. Test mode can test the front panel LEDs and outputs without external test equipment. Universal CT available for the non-drawout relay, and CT secondary is software selectable, so there's less order code and more flexibility for future design change. Programmable LED is available. User can customize the LED display. M2 family migration to 3 series platform is simplified with retrofit tools and setting file conversion in the software. There are 3 types of 3 series relays. 350 is used for feeder protection in medium voltage and high voltage utility and industrial. It can be changed to a voltage relay by changing the order code, and also it can be used for capacitor bank protection. 339 is used for the protection of low voltage and medium voltage motors of various sizes. 345 is used for the protection of 2-winding power transformer, reactors, and auto transformers. This is summarized in this comparison table. So from this table we can see each type of relay, what functions are available, and also for the
IEC 61850 logical node is also provided in this table. For example, we can see that the current element 50P, 50 breaker failure, BF, neutral and ground, negative sequence. These are common for all three relays. Same for the time over current, phase and neutral and ground. And some protection element just very unique for certain protection. So for example, the motor protection got its undercurrent, under power, and RTD unbalance, current unbalance. For the transformer, it has its unique protection is the differential. It has the percent differential and also the restricted ground fault, 87G. There's one element 49 thermal model. It's shown here for all three relays, but there's some difference between each type of relay. For the feeder relay, the thermal model is cable thermal, and for the 339 motor, it's a motor thermal model, and the transformer has it's a transformer thermal model. So each calculation, the algorithm is slightly different. So that's the whole comparison of all three relays. So if you want to go to more detailed information, for example, the thermal model, you can go to the manual for the detailed description of that function. Now I'm going to demonstrate how to use online store tools to configure the order code for 3 series relay. So first we go to the GE website, store.gdigitalenergy.com, and in the search type 350 and search for 350 feeder relay. Then we click 350 feeder protection relay buy now button. And from this configuration tool, we can see this product options below. So by selecting each options, you can automatically update the order code on the top. For example, if I want to select the current protection to be advanced configuration, I just select from letter E to letter M, and then order code is automatically updated on the top. And this is a good way to configure a valid order code, because there are some contradictions between each letters. So this way will guarantee you create a valid order code for the.
In the front panel, there are 4x20 characters LCD display screen allows visibility under varied lighting conditions. When the keypad and display are not being used, system information is displayed after a user-defined period of inactivity. Any trip, alarm, or pickup is displayed immediately, automatically overriding the default message. If the keypad is inactive for the preset screensaver time, the relay automatically shuts off the display screen. Below the display screen are the status indicators with 10 LEDs for the non-programmable type and 12 LEDs for the programmable type. These LEDs will show the status of the relay operation and status of the breaker, or for the motors or the transformers, depends on the application of the relay. LEDs can be in red, green, or orange color. The keypad allows users to navigate through the hierarchy relay menu, change the set points, and reset the trip alarm status without using a computer. In addition to the front panel operation, USB port is intended to connect to a PC loaded with InnoVista SR3 software. Setting file can be created offline and then downloaded into the relay with this port through the program. Next, we'll talk about more details of the LEDs. In this training modules, we'll only talk about LEDs of the 350 feeder relays. For 339 motor relays and 345 transformer relay, we are going to introduce their own LEDs on their specific module. In service LED will turn on to green when the relay is set to ready in the setup menu and no major self-test error has been detected. Trouble LED will turn on to orange when the relay is not programmed or upon detecting a major self-test error. Setpoint group 1 or 2 LEDs will turn on to green color to indicate the group of active protection elements. If setpoint group 1 is lit green, only the protection elements under group 1 will be active. The protection elements from group 2 will be inactive, vice versa. Trip LED will turn on to red color when the relay detects a fault and sends a trip command to the trip output relay. The LED will reset by reset push button or the software when the fault condition has cleared. Alarm LED will flash in orange color upon detecting an alarm condition, with element function selected as alarm. The LED will automatically turn off if the alarm condition clears. The LED will remain steady on if the function of the operated element is selected as latched alarm. Pickup LED will turn on to orange color upon pickup condition generated by any of the relay feature. The indicator will turn off if no pickup condition is detected. Breaker open LED can be programmed to red or green color. When the breaker is open, the indicator will be on continuously. Breaker closed LED is also programmed to red or green color. When the breaker is closed, this indicator will be on continuously. Breaker status indication is based on the breaker's 52A and 52B contacts. With both contacts wired to the relay, closed breaker status is determined by closed 52A contact and opened 52B contact. Vice versa, the open breaker status is determined by opened 52A and the closed 52B contacts. If both 52A and B contacts are open or closed, the breaker is racked in the switchgear. Both breaker open and closed LED indicator will be off, and the relay will display breaker status fail alarm message, and alarm LED will also flash in orange color. Front panel with programmable LEDs has 12 LEDs. The first LEDs are dedicated to in-service, trouble, trip, and alarm. Same color convention as non-programmable LED. The second column is for the source signal programmable LEDs. 1 to 4, LED 1 is red, 2, 3, 4 are in orange color. The third column is for LED 5 to 8. They are programmable in source signal and also in 3 colors, red, orange, and green. There are 5 main menu headers in the hierarchy structure: actual values, commands, quick setup, set points, maintenance. With message for arrow keys, user can easily scroll through the page headers and subpages. The enter key can be used to enter the subpage and to store the altered set points into the memory. The escape key can be used to exit the subpage and to cancel a set point change. The value key are used to scroll through possible choices of an enumerated set points. They also decrement and increment numerical set points. A reset key resets any latched conditions that are not currently active. This includes resetting latched output relays, latched trip LEDs, breaker operating failure, and trip close coil failure. The auto-reclose scheme can also be reset with the short counter being returned to 0 and the lockout condition being cleared. In the drawout type relay, the terminal A1, B1 are used for the AC-DC power supply. B2 is used for the ground. The rest terminals A2 to B12 are used for output relays. Column C1 to C11 are for the inputs. C12 is for the chassis ground. In the column D and E, 5 to 8 are used for the current inputs, 9 to 12 are used for the voltage inputs. For 345 transformer relay, they are all used for the current inputs. In the non-drawout type relay, the terminal L and N are used for the AC and DC power supply. Ground port is also provided in the same connector. The whole column A1 to A21 are used for the output relays. Column B1 to B11 are for inputs. B12 is for chassis ground. In the column D and E, CT-VT inputs are the same as drawout type relay. Power. The power supply to the drawout type relay is wired to the terminal A1 and B1 and grounded on B2. For the non-drawout, power supply is wired to the terminal L and N. According to the order code of the relay, there are two levels of the power supply, low and high. The range for the low power supply is 24 to 48 volts DC, and for the high range is 125 to 250 volts DC or 120 to 240 volts AC. Control power supply to the relay must match to the installed power supply range. 3 series relays has 10 digital inputs. C1 to C10 are for drawout type and B1 to B10 are for the non-drawout type. These contacts are wet contacts, and the inputs should be connected to the positive terminal of an external DC power supply. The negative side of the external source must be connected to the relay's DC negative rail at terminal C11 for DC drawout type and B11 for non-drawout type. The inputs can be programmed to different thresholds depends on the DC voltages. There are 4 threshold levels, 14 volts, 33 volts, 84 volts, and 166 volts DC. The maximum external source voltage for this arrangement is 300 volts DC. 350 feeder relay is equipped with 7 electromechanical output relays. 2 special relays from A type are designed for breaker, trip, and close, then for general purpose relays 3 to 6. And the last one is critical failure relays. Relays 3 to 7 are all from C-type relay. For drawout type relay, terminals are from A to B12, and for non-drawout type relays, the terminals are A1 to A21. Breaker monitoring, including trip and close coil monitoring, is performed by built-in voltage monitor on Form A output relays. Number 1 is for trip and number 2 is for close. The voltage monitor is connected across each of the 2 Form A contacts, and the relay effectively detects healthy current through the circuit. In order to do this, an external jumper must be connected between the terminals A2 and A3 for trip coil monitoring, and B4 and B5 for closed coil monitoring. As long as the current through the voltage monitor is above the threshold of the trickle current, circuit integrity for the trip or closed coil is effectively normal. If the trip or closed coil circuits get disconnected, or if in general a high resistance is detected in the circuitry, a trip or close alarm will be set and the alarm maintenance LEDs will be on. 350 and 339 relays have 4 AC current inputs and 4 voltage inputs. 345 relay has 8 AC current inputs. The terminals are from E5 to D12. Same for the drawout and non-drawout. 3-phase inputs are designed as a bus voltage, and the connection most commonly used are Y and open delta. The single-phase inputs is designed as the auxiliary VT voltage. Auxiliary VT input channel can be connected for either phase to neutral voltage VAN, VBN, VCN, or for phase-to-phase voltage VAB, VBC, and VCA. For the Ethernet ports, there are RJ45 copper Ethernet or MTRJ fiber optical cable connection. The serial RS485 two-wired communication port is provided on the terminal F3 and F4, which can daisy chain up to 32 3-series IEDs. ARIC B is a standard time code that allows time stamping of events to be synchronized among connected devices within 1 millisecond. The wiring for the ARIC B is on the terminal F1 and F2. The drawout unit can be drawn out while the captive screw is loosened and handle is rotated 90 degrees. Inside of chassis, we can see the magnetic modules sits at the bottom left side. It can prevent CT open circuit while relay is removed from chassis. On its top are the comms card and column F. On the right side are the columns A and B for the inputs and outputs.
When the USB cable is plugged into the front panel USB port of 3 series relay, we can double-click the SR3 icon on the desktop to start the SR3 setup software. There are 5 steps to do the quick connection with the USB port. So first is to go to the printer devices and to verify the USB port. And in this setup, the USB port is COM4. And step 2 is to click the Quick Connect on the software. And step 3 is to make sure to choose the correct COM port. Now we have only COM4 available. And step 4 is to click a Connect button. And step 5 will see the Quick Connect ended to the site Quick Connect message box, and we'll connect OK, and we can see this Quick Connect is ended under the Quick Connect site. The quick connection can be established not only through the front panel USB port but also through the Ethernet port. To use the Ethernet port, we need to set up the IP address of the relay. There are 5 steps to do this IP address setup. Step 1 is to connect the Ethernet cable to the RJ45 port on the back of the relay. And step 2 is to go to the relay setup, communication, and set up the IP address. So in this case, we're going to use 1.1.1.1 as example. And step 3 is important, depends on what type of the connection. You can choose copper or fiber. So since we're using RJ45 port, I'm going to choose copper, but you can also choose the fiber optical cable for this Ethernet connection. And then we need to click the Save. Then step 4, and step 5 is to change the PC local area connection address. So we can start the local network adapter settings and change the property. Choose TCP/IP v4 and enter a different IP address. To verify this new IP address of the relay is ineffective, so we can start the command and use the ping command to verify this new IP address. And now we can see this response means this new IP address is take effective. Once the IP address is effective, we can add the relay into the device setup. There are 5 steps to do this device setup. Step 1 is to click the device setup button and click End Site. We can give this site a name. We can call this Markham. And step 2 is to end a device. We can click End Device button and give this device a name, 350. And step 3 is to choose the interface to be Ethernet. And step 4 is to type in the IP address we just set up by using the USB port. Unless you change the default slave address and Modbus port, we're just using the default 254 and 502, and this setting can be verified by using the front panel or using the USB front panel connection. And the last step, step 5, is to click Read Order Code button. And now this order code is read in this device setup, and now we can also see the firmware version is 2.2, and that's how we set up this device setup. And if we click OK, we can see this Markham and 350 relays is created here. Status can be found under Actual Values A1 Status. Just double click Status A1 and we can check the status for the clock, contact inputs, output relays, logic elements, virtual inputs, remote inputs outputs, goose status, and 61850 status. So here give one example for the contact inputs. We can double click contact inputs and use a pre-wired test set to apply the DC to the contact input 1 to 4 by turning on the switch 1, 2, 3, 4. We can see the status changed in the contact input 1. Then we can turn them off one by one. So you can see the status changed. It's the same way we can verify the status for the output relays, logic inputs, virtual inputs, and remote inputs outputs in the following modules. Metering is under the Actual Values A2 metering. Double click A2 metering. We can see the metering for the current, voltage, power, energy, demand, and thermal capacity. So if we open the current, we can see the 3-phase current for this application. And if we open the voltage, we can see this is the voltage meters with the phase to neutral and phase to phase voltage for the Y connection. If the VT is configured to delta connection, then only the phase to phase voltage will be displayed. There's also the positive and the negative sequence voltage, and this will be useful when we doing the positive sequence under voltage testing. We can use these metered values to verify the pickup values levels, and also the auxiliary voltage frequency metering in this voltage screen. And other metered values we can see is the power, energy, and also the current demand and voltage demand. And for the thermal capacity, this is only for the 350 relays cable thermal capacity, and later we will come to the 339 motor relay will get a different thermal capacity display. 3 series relays provide 3 types of records: event records, transient records, and fault report. To launch the records, we can go to the actual values and click A3 to click on each items, event records, transient records, or fault records. Or we can go to the shortcut toolbar, click the shortcuts for the event records or the transient records, also called complete records. So now let's click open the event records and see what happens. In these records, we can see the numbers. We can have a pull-down list to select the events. When you select the events, all these events will be displayed. For example, 466 is a phase C IOC trip operation, and you can see the parameters, current and voltage, phase angle, etc. displayed. You can save this events, or you can clear these events. So for example, if you save, you will save as a CSV file. And second is the transient record. I will launch from the shortcut. By clicking this complete record shortcut button, we can launch the waveforms. So this waveform is captured while the relay operations. This can be preset, triggered by 4 operations: pickup, trip, dropout, alarm. All can be triggered by 3 inputs. These 3 inputs can be configured to be contact inputs, virtual inputs, remote inputs, or logical elements. So now I started the waveform of the 3-phase voltage and current, and I can drag and zoom in this pre-fault to fault conditions. So for example, I can see the relay operation, output relay. I can, by moving the cursors, I can further zoom in. So we can see that from the pre-fault jump to fault, the time difference is like 1 cycle, 17 milliseconds. And for this waveform, we can just dragging and overlay them. So I'm overlaying the 3-phase voltage. And we can also see by moving the cursor, we can see the magnitude changing. For example, the voltage. So this is the peak values. Okay, so now it's the maximum. For the phase C 168 volts. There are also a configuration for the preference. So by going to the preference, you can select which channel to be displayed, or you can even select the colors for different phase. According to your country's convention, you can pick a different color. And for the display, you can choose this to be automatic, or you can just disable, set to none. So in this example, I'm just going to show only the 3-phase voltage. So now I changed the color and also disabled the display of the currents. And from this transient recorder, we can also see the phasor. By clicking the phasor, we can see the three-phase vectors and also the values, 120 volts, 0, 120, 240 degrees. And if you want to set the second group, so you can choose current and voltage. So you can show two phasors. So that's lots of information included in this transient recorder. It's a very useful tool for the troubleshooting. And the last one is the fault report. We can only launch the fault report from the menus, actual values, A3 records. There's no shortcut, and from this fault report, we can see a more detailed information on the type of the relay order codes, version numbers, the fault date, and what type of the fault. So it's much more information than the event recorder. The last piece of the actual values is very important. It's the relay order code, firmware numbers, and the serial numbers. And for 3 series, this is different with other multi-link relays like UR relays or 8 series relays. For these relays, the order code and the firmware number, serial number are under the actual values. But for the 3 series, this information is under the maintenance. So in order to check the relay name, order code, firmware version, and the serial number, we need to open the maintenance and click M1 relay info. And there are lots of information in this M1 relay info. And most important 4 items, I would pick the relay name. That's configurable under the installation. And then, of course, the relay order code, what type of the relays, what are software options, what's the firmware, 2.2, are you using the latest one, so you can know from this firmware. And another one is the serial numbers. So serial number will be important if you have any problem with the relay, you want to contact the technical support, you need to provide the serial number of the relay. And other information like a MAC address will be useful in the future 61850 configuration, and other information. It's good to know they are saved under the M1 relay info, but we don't need to use them very often. To access to the front panel HMI display, we can go to the actual values and click 350 front panel and then click HMI display. And now we can see this exactly the same display as I have on the relay front panel. So now I got one fault current injected to the relay, and I can see the relay operated in the front panel. If I press the reset button, the message won't go away because the fault is still applied. So if I clear the fault and now press the reset button from the HMI display with the software instead of front panel, I can see that message is disappeared. And also we can just access to the main menu by pressing the menu key. We can scroll down the menus for the actual values, command, quick setup, set points, and just by pressing enter key we can just go into each settings. For example, we can go to the relay setup and set the front panel installation. So from the installation we can select the relay name, status ready. We can change from here to ready, from ready to not ready, and press enter. So once we saved this relay not ready, we can see that trouble light turned on. Okay, so if I want to change back, using the value key to change to ready and then press enter. So now the relay is back in service, green light is turned on. So whenever what you can do from the front panel, you can just do from this HMI display in the software. When series relay is received from the factory, the relay status is not ready. So we need to set the status into ready. The setting for the status is under Set Points, S1, Relay Setup, and Installation. Double-click Installation, we can change the relay status from not ready into ready and click Save. And then we can see the front panel LED will turn on to green color for the in-service. Another setting for the initial setup is to set up the clock. Because if a clock is not synchronized with the computer, you get a target message, clock not synchronized. And in this relay, it's already synchronized, but if you have a relay not synchronized, just open the clock and click Sync Relay to Computer and click Select. And then the computer date and time will be synchronized to the relay date and time. Transient recorder is a very useful troubleshooting tool. In order to get a perfect COM-treat file, we need to properly set up the transient recorder. So to get into the transient recorder, we go to the Set Points, Relay Setup, and Transient Recorder, double click, and there's lots of settings we can do with the numbers of the record. We can pick the 1, 3, or 6. So when you choose less numbers, you can record a much longer waveform. And sample rate, we can pick the 4, 8, 16, or 32. So you have a higher sample rate, you have a better resolution of the waveform, and then you have a shorter waveform can be captured. In the trigger mode, we have the override and the protected. If it's protected, that means the waveform will save to a certain amount and then stopped. If it's override, that means the new waveform will always override old waveforms. And the waveform triggering position can be set from 0 to 100%. And we're using 20% here. And trigger can be done by 4 operations of pickup, dropout, trip, and alarm. And also by 3 inputs. And these 3 inputs can be set into 4 different digital inputs that are remote inputs, contact inputs, virtual inputs, or logic elements. So totally we can have 12 digital Boolean inputs to trigger this waveform, plus the 4 of the operation. So that's the setup for the transient recorder. System setup is an important part of the relay setting. Under system setup, we can set up the current sensing, voltage sensing, power system, breakers, flex curves, etc. We're going to talk about the breaker setup in the later platform modules, and in here we just introduce how to set up the CT, VT, and the power system. So to set up the CT, we go to the system setup and click current sensing. And here we can see the CT primary current, and we have 3 ways to change this setting. The first one is by clicking the cell and using the arrow key to press up and down to change the new values. The second way is to click this enter key, start the keypad, and using the keypad to type new values and press equal sign. And there's a limit, so maximum is 6,000. So if you press a number higher than that limit, you get a message, and it just limits it to 6,000 amps. And the last one is just directly highlight this number and type in the new settings from the keypad, and press a tab key and click save button, so the new setting is saved into the relay. If the relay has the order code of universal CT, then secondary current 1 amp or 5 amp can also be selected from the software. Under the voltage sensing, we can set up the VT connection, Y or delta. We can set up the bus, VT secondary and ratio, auxiliary VT input, secondary and ratio. For the VT secondary, it should be the secondary nominal voltage. It needs to be line to line for the delta and line to neutral for the Y connection. And here is one example. On a source of 13.8 kilovolts line-to-line voltage with a VT ratio of 14,400 to 120 volts delta connection. Then the secondary voltage to be entered is 115 volts. For Y connection, the voltage to be entered is 115 divided by root 3, that's 66 volts. And under the power system, we can set the nominal frequency to be 60 Hz or 50 Hz. And then we can choose the phase rotation to be ABC or ACB, and also we can select the power unit, kilowatts or megawatts. And that's the setup of the system setup. Next, we'll use Face ILC as example to show some common set points. So to access to Face ILC, we can go to Set Points, Protection S3, and Set Point Group 1, then click Face ILC. The first setting for the Face ILC 1 is the function. On the function, we can choose Disable, Alarm, Latched Alarm, and Trip. If the function is set to Disable, means this feature is not operational. If the function is set to Alarm, means this feature is operational. And when the alarm happens, this function will operate selected auxiliary operate relay, and LED on the front panel will flash on alarm. And alarm condition will self-reset when the operation condition is cleared. If the function is set to latched alarm, the whole operation is similar to alarm, except that condition will stay on even the operating condition is cleared. So the reset button is needed to clear the alarm condition. If the function set to trip, that means this will trip the trip relay, that's the output relay number 1, and also other selected auxiliary relays, and also turn on the trip LED on the front panel. For the pickup level setting, it selects the how much current needed to operating the Face ILC pickup. And once it's pickup operated, the relay need wait for the time delay in the delay setting to turn on the output relay. The directional setting is used to define the direction of the relay, so this will work with the Face ILC directional element. We can choose disable, forward, or reverse. And for the auxiliary relays, we can select relay 3, 4, 5, 6. If the trip happens, we can trip other 4 relays together with trip, or if the relay set to alarm, only the selected relay will operate. And this function can also be blocked by 3 inputs, block 1, 2, 3, and under each inputs we can select contact inputs, virtual inputs, logic inputs, and remote inputs, and other conditions. And this is a common setting in the Face IOC, but it's applicable to all the platform protection elements. And Vista SR3 setup software provides a summarized setup for the most often used settings in Quick Setup. When the user needs just a simple application of the 3 series relays, they can using Quick Setup to set up the relay and some basic protections. So if we go to the Quick Setup, double click, we can start this one screen setup. We can set up the relay from not ready to ready and select the nominal frequency, and we can select the CT primary current and also the ground CT, VT connections, secondary ratios, and the auxiliary VT secondary and ratios. We can also select the phase TOC, pickup, curve, and time dial. And we can also do the same for the ground TOC and neutral TOC. We can also set up the phase IOC for the trip and pickup levels. If you want more detailed settings, you need to go to that element to set up the more informations like the delay or the blocking, the directional. But if you just need a basic protection, just operating pickup levels, so this can be quickly set up a relay into service without going to detailed setup screen. So click Save, so all this information is saved. Another way to do the quick setup is going through the protection summary. Under the protection summary, we can check what element being enabled and what relay has been assigned for both group 1 and group 2, and we can also check the control elements like the logic elements and also the maintenance for each setup. So under each element, if it's enabled, we can see it's in the green color, and from the top we got option, we can choose elements to show to be all or enabled. If we click enabled, we only see the enabled function. Click all, we see all the protection elements. And we have a shortcut into that element by clicking the button. So we can start the phase TOC, and under phase TOC we can select the output relay. For example, I choose 3, 4, 5 and click Save. Close this setup screen. Now I can see from this summarized screen, I can see the relay R3, 4, 5 being checked. So that's the very useful tools. We can see the two groups of the protection element and also assigned output relays. We can see the control elements and maintenance functions, and we can select elements to be displayed or only enabled. To download a setting file from online portion to the offline portion, we need to right click the device name and choose read device settings, and then we can give this device a name 350 and click receive. And now we can see this setting file is being downloaded from the relay into the offline setting area. So once the download is finished, we have this offline setting files, and what we can do with this is to duplicate the setting files. We can right-click mouse and choose duplicate setting files. So on this copy, we can play with the editing of the setting files. Right-click again, we can choose Edit Setting Files Properties. So under Editing, we can change the firmware numbers. For example, change 2.2 into 2.0. In order to upload this setting file into a lower version, we can change the serial number lock. That guarantee the download of this file only to a particular serial number. And we can also even change the order code by using these editing functions. So just change the firmware version and click OK. Another thing we can do with this offline setting files is compare two files. So for example, if I duplicate another copies and I can make some 3 changes in the current sensing. Y to delta and frequency into 50 Hertz. So if I make 3 changes, I can compare this setting file with the original setting file. Okay, so just right-click original setting file and choose compare two setting files. We pick this copy of copy. And now we can see the 3 differences in this setting files. So the 3 differences are the CT primary, 1000 to 2001, VT connection, Y to delta, and 60 Hz to 50 Hz. Okay, in order to write a setting file back to the relay, we need right-click setting file and choose write setting file to device. So I'm writing this copy of copy back into the relay 350 and click send. And now this new setting file is uploaded back into the relay. Okay, so we can go to the relay online portion and open the set point just to check that new setting being uploaded. So CT primary for the power system, 50 Hz. That's the setting file being updated. Another thing we can do with this setting file is create a new setting file in the offline area without having any relay. So right-click mouse and choose new setting file. From new setting file, we can give a name and we can choose the version number. We can select the order code. So for example, I'm going to choose this relay called feeder 1 again and give a version number 2.2 and select a different order code and click OK. Now this feeder 2 relay is uploaded and we can see because I picked a P0, that's a universal CT, I can see the CT options for the secondary 1 amp or 5 amps. Okay, another thing we can do is to import the MI series relay setting file into the 3 series. So again, right-click mouse and choose and new setting file, and we can have a checkbox at the bottom is called initialize setting from MIF to MIV setting files, and we can select the setting files. I got one MIF setting file saved here. .txt file. I just click open and click OK. Then this MIF setting file is converted into 3 series, and we can see the different settings comparisons. We know the green color for successfully converted, orange color for need verification, and red color for need manual configuration. And lastly, we can print the setting files by using this offline print setting file functions. We can do a print preview, and we can select the setting files. If it's online portion, we can also print the actual values. So this is the setting files we can print. Clicking the next page, and to view all these setting files, this either can be printed into a printer or it can be converted into a PDF file. And that's all what we can do with the setting files, from online to offline, and lots of editing, comparison, importing, etc. In the application example of 350, we're going to test 350 auto-reclose by using 850 as a breaker simulator. First, we're going to use hardwired connection between the 350 to 850. We're going to also set up the transient recorder to capture the waveform of the 4 shots auto-reclose. Then we're going to remove the hardwire to the contact inputs of the breaker simulator and configure the goose message. There's 2 ways to program this goose message we're going to introduce, and this is the workshop exercise in the 3 series program and also MTDT motor and distribution program. Before configuring the 350 auto-reclose function, we need to do the wiring between the 350 to 850. There's a wiring diagram in the tools provided in the 3 series program. It tells how to wire the 350 relay to 850 breaker simulator. And depends on what type of the 350 relays, we have non-drawout and the drawout type. And in this demo, I'm using drawout type, so I choose drawout type relay and wire the relay from 350, trip, close, 50A and B, and AC current input connecting through the RTT test set to the 850 breaker simulator. Then in the 3 series setup software, we need to configure first is the system breaker. We're going to use the contact input 1 to simulate breaker close and open. We're not using breaker 52B in this exercise. Then we need to configure the auto-reclose. So in this auto-reclose, we configured 4 shots, and for simplicity, we used 1 second for each shot dead time. On the 850 side, we need to program a flex logic. So we're using a flex logic contact input. So this is the offline setting file, breaker simulator, with 2 contact inputs. So contact input 1 from the close from the 350 relay, and contact input 2 from the open or trip from the 350 relay. This through a latched gate and assigned to the virtual output 1. Virtual output 1 will be assigned to the output relay 3 and 4. So 3 and 4 will be used to control the contact input of the 350 relay. So that's the auxiliary 3 to simulate the auxiliary contact of the breaker. That's the status of the breaker. Then auxiliary 4 will use to cut the AC current injected to the 350 relay. Okay, so now we're ready to do the test. I'm going to use the HMI display of the 350 relay to close the breaker. So we can use the mouse click instead of pressing the front panel. So I choose the command. We can see that the breaker started, now it's open, so I choose close and choose close to be yes and press enter, and now I can see the breaker is closed. And from the target message I can see my auto reclose is ready. And by the way, I need also inject the trigger for the auto reclose. In the setting I used Face IOC. Face IOC initiate set on, so I need to make sure my Face IOC is enabled. Go to the protection, Face IOC, and function is set to trip. Pickup is 0.1 CT. So now I'm going to use the RTT test set to inject the current to trip the Face IOC. Okay, so now I see the Face IOC tripped. I heard the relay operated multiple times. That's the trip, and auto reclose function work together. So totally it should operate 4 times. And at the end we can check the waveform by clicking this display complete record. And because this takes some time to download the waveform, I got a recorded waveform. I can recall from here. So now the waveform is being downloaded from the relay. Okay, so now I can see this captured waveform is with 4 shots. So on the top is IA, channel A current. I gradually increase the magnitude until it operates to trip the Face IOC. And contact input 1 is a 52A. Initially it's closed. Then when the relay operates, that's the trip relay. It trips, starting the auto reclose, initiates the auto reclose. So if I can zoom in this shot 1, I totally got 4 shots, but if I just see the shot 1, I can see that from the breaker initiation to the auto reclose, the relay 2 is a closed relay. So I can see that the time, dead time of this shot 1 is 1.008 second. So that's the setting of our 1 second. And we have this same 1 second for the whole 4 shots. And that's the first part of this auto reclose testing by using the hardwired. And now I will introduce the second part of the test by using the goose message. Instead of using the hardwired, now this wiring from the 350 to 850 contact inputs will be replaced by the goose message. In the 3 series configuration, we're going to set 4 remote outputs. We're going to do this by using the advanced goose. So we have one offline setting file, 350 AR goose. We need first make sure that the communication is in the advanced mode, and then under the 61850 configurator, we're going to publish 4 outputs. So that's the under transmission, and this is the 4 outputs we drag and drop from the GGIO3. That's the virtual input 1, which will be used for the menu close the breaker. Then we get the second is REC. REC stands for reclose. So the second one is auto reclose goose message. The third one is GGIO3 again, virtual input. Second, virtual input 2. This will be used as the menu trip. And the last one is the face IOC pickup. This will be used to trip the breaker, to reset the breaker status. So we use manually close the breaker or automatically closed by the REC. Then this will be manually opened by virtual input 2 or automatically opened by the face IOC pickup. So that's the goose message we're going to publish. So from the offline setting file, we can generate the CID file by right-click offline setting file. We can choose export CID file, and this CID file will be imported into the 8 series. So now let's take a look at the 8 series. So the 8 series, we got a file called the breaker simulator. Under this file, we first need to configure the flex logic, the logic designer. We're intaking 4 remote inputs. So from here we got input 1 and 2 remote is used for close the breaker. This was sent to the S of the latched gate via OR gate. Then remote 3 and 4 pass through the OR gate, sent to the R of the latched gate. This will be assigned to the virtual input 1. And the virtual input 1 will be assigned into the output relay. So output relay 3 and 4. If you need to review the diagram of the wiring. So we can just take a look of this wiring for the goose configuration. So we using 3 and 4 to control the breaker status and the AC. So we're just not using the top one, and this part is done by using the goose message. Okay, so 3 and 4, it will be used to control the breaker simulation. And also, in order to check the remote input status, we set the transient recorder, the coming for the remote input 1 and 2. So that's from the breaker, manual close, automatic close, manual trip, and automatic trip. So that's for the breaker setting simulation from the 8 series side. Now we go back to the 3 series. The 8 series, we need also import the CID file from the 3 series, which is under the 61850 configurator. So from the goose reception, we already received the goose message, which I renamed this to SR360, but that's the goose published from the 350, GGIO 3, reclose, REC, GGIO, virtual input 2, and face IOC pickup. So this will be received by 8 series and used as its remote inputs. Okay, so now we're going to go back into the 3 series and start the auto reclose process. So once the setting file is written to the both relay, we need to reboot the relay to make the 61850 effective. Then first thing, we can start the display of the front panel. So we see now the breaker is in open status. We can manually close the breaker by using the virtual input 1. So virtual input 1 should be enabled under the virtual input 1. We enabled both 1 and 2, and be careful here, the setting is self-reset mode. We cannot use the latch mode. Now we're going to use the command under control, virtual input command. We're going to manually close the breaker, and this LED should turn on. So I heard the relay clicked, and now I see the status is in the closed position. The breaker is closed, and I can reset the front panel trip. From the target message, I see the AR ready, so it's ready to do the auto reclose. So now I'm going to ramping up the current from the RTT and wait for the auto reclose start. Okay, so that's the 4 shots of the auto reclose. Now, if we want to check the waveform of the 3 series, we can launch the waveform. And meanwhile, we can also check the remote input from the 8 series. So we can also start the waveform of the 8 series. Okay, so now the 350 setting download is finished, so I can see that the pickup and output of the trip, which is a relay 1, we got the AC increased until the 4 shots of the reclose, and this is the relay 2 is the close. We got 4 shots of the reclose. The time between this are the dead time setting of the relay. The 8 series waveform by logging to as an administrator. Okay, so this is the remote input 3 and 4. We can just remove that analog values by choosing the preference. Okay, so this is the remote input 2 and 4. So remote input 2 is auto reclose, and remote input 4 is the pickup of the phase ILC. So once the reclose, turn on the virtual output 1, turn on the auxiliary 3 and 4. This will apply the current, and this will cause the 350 to trip. Come back, 350 publish a remote output message to the 850 received by remote input 4 of the 850. So that's how this whole process working. So that's the demo of the auto reclose by using the goose message between the 350 and 850. 350 publishing 4 remote outputs and received by 850 as the 4 remote input. Then the logic design is on the 850 side by using the logic designer tools. There's another way we can do is by using the logic element of 350 and pre-process the signal into 2 logic elements and publish to 850. Then 850 only need 2 remote input. So this is we can use the power of the logic element of 350. So under the logic element, we can enable this logic element 1 to be control, asserted on. Then the trigger of 2 inputs. The first is virtual input 1 on, and then the trigger source is second is auto reclose. The second logic element, we can use the virtual input 2 for the manual trip the breaker, then the phase ILC pickup to trip the breaker. So once this two virtual to this remote input, we can, under the 61850 configurator, we can publish this to be the GGIO4 is the logic element for 3 series. So we publish GGIO4 1 and 2, that's logic element 1 and 2. And this will be subscribed by the 850. So on the 850 side, now the logic designer can be simplified. So first, this will receive 2 of the GGIO4 from the 350 as a remote input under the logic designer. So logic designer, we don't need 4 inputs. Now we need only 2 remote inputs and assign to the S and R of the latched gate, then to the virtual output. So that means that OR gate is being used on the 350 side. So we're balancing the logic design between the 2 relays. Okay, so that's how this works. And again, this virtual output 1 will be assigned to the auxiliary relay 3 and 4 to control the circuit breaker 52A and B, then the AC input. So to make this work, this setting will be uploaded into the relay and reboots both a relay. So once this is done, we can just start the front panel of the 350 and do the manual close of the breaker by using the virtual input 1. Okay, so now we see the breaker now status is open. Okay, so we can reset the front panel trip LED. We're going to close the breaker by using the command. Okay, so once the relay is virtual input 1 is closed, we can see that the breaker status is closed. Now the auto reclose is ready. We're going to use RTT to inject the current and see the auto reclose of the 4 process. Okay, so that's the 4 shots of the auto reclose. Then we can launch the oscillography. Okay, so now the waveform is downloaded. We can see that the AC current applied caused the breaker to open, tripped the relay on the relay 1. Relay 2 is the close. The 4 shots of the reclose, that the time is the dead time settings. Each time is a little longer. Then because we enabled the logic elements, so we're using the logic element 1 and 2, that also being assigned to the trip and the close. So the logic element 1 is associated with the manual or auto close. Then the element 2 is for the trip. From the 8 series side, we should see the remote element, remote input from the logic element of the 350. Okay, so the 850 side, we can see that the remote input from the logic element 1, then remote input 2 from logic element 2. So we can see that the 4 shots of auto reclose on the 350 is reflected on the 850 side. And that concludes the demo of the auto reclose. Just to do a quick recap, we did first by using the hardwired between the 350 and 850. Then we tried a goose message to send between the 350 and 850. There are 2 ways we can send the 4 remote outputs to 8 series and process by the 850 flex logic designer, or we can use the logic element of the 350 and do some pre-processing and then publish just only 2 remote outputs, and 850 use these 2 remote inputs to set their latch gate. So there are always different ways to program this goose message, the processing, the protection scheme. So that's concludes this demo part of the auto reclose. Now let's answer some questions collected from the chat box. One question is asking about where's the introduction of the 350 feeder relay auto reclose function before the demo of the auto reclose. The answer is that due to the time limitation, we cannot show each application relays like a feeder, motor, transformer. So these application relays have individual training modules which can be watched on the YouTube channels, the GE Learning and the Development. So you can just watch each modules to learn more detailed about the protection functions of each applications. Another question is from the customer asking about the arc flash function is a unique feature of the 350. So it's not introduced in this webinar. Again, this is because we're going to do another webinar about the arc flash, which will be comprehensive from the theory of the arc flash until the GE products from the A60, 350, and the 8 series with a demo with 8 series. So that will be included in that arc flash webinar about 8 series. So we don't waste some time on this 3 series. And last one, this is a really good question. That's a good observation. He asked about that during the demo of the goose message with the 4 remote inputs in the oscillography, 8 series only showed like one remote input. Like it didn't show that 4 shots of the auto reclose, while in the second demo of using the 2 remote inputs, the 8 series showed 4 shots auto reclose, so that remote inputs turned on off 4 times. So why in the first demo it only showed once? The answer is it depends on the setting of the transient recorder. By default, the setting is 5 records, and when you have more records, so the duration of each record is shorter. In the second demo, I changed the record to be only 1, so then I can have a longer duration for that record. So that's why we can see the 4 shots of the remote input, and that matched to the 350 side of that auto reclose and logic elements 4 shots. Okay, so that's just some questions I collected from the chat box, and so that's concludes for this Q&A session. Now let's recap what we learned in this webinar. In the beginning, we did overview of the 3 series, the features of the 3 series, functions, the communication protocols, and the 3 applications, feeder, motor, and transformer. And we also did a comprehensive ANSI code comparison of each function of the different type of the relays, as well as the IEC 61850 logic node. In the hardware session, we showed the different front panel, drawout and non-drawout, as well as the programmable and the non-programmable LED. On the rear side, there's also different terminal configuration for the drawout and non-drawout relay. In the software, we showed how to configure the relay IP address out of the connection by using quick connection and the configure of the site and the device, which is the setting file, read and write, editing, comparison, basic operation of the software. In the application example, we did one auto-reclose function of the 350 by using 850 as the breaker simulator. First, we used the hardwired connection to wire the 850 to 350, configured the transient recorder, and captured the 4 shots of the auto-reclose. After that, we explained how this test can be done differently by using the goose message, so that wiring from the 350 to the contact input 1 and 2 to 850 can be removed. And that's a kind of simplification of the test setup. And then conclude this 3 series webinar.